Hello everyone. Let us now discuss about logistic regression. So logistic regression is a very important machine learning algorithm. It is also asked in most of the interviews. So it is very important to deep dive into the concept of logistic regression. If you have not subscribed my channel before, please subscribe my channel. You can give like and comment also. So let us now understand the concept. Let me introduce myself. I'm Premlata here. So let us now continue with the concept of logistic regression. So what is meant by logistic regression? Before understanding what is logistic regression, we should try to recall what is linear regression. So what is linear regression? In linear regression, the dependent variable is numerical, right? But in logistic regression, the dependent variable is categorical. So how can we understand this? Let me give you one example. Based upon the number of hours of study, we predict the marks of a student. So let me write it over here. Based upon the number of hours of study, we are trying to predict the marks of a student. So what is mark? Mark is the dependent variable. Is this numerical or categorical? It is numerical. So tell me now whether it is regression or classification. Exactly, it is a regression algorithm because the dependent variable is numerical. In case, based upon the number of hours of study, if I am trying to predict the result of a student, the result may be like a pass or fail. It is basically categorical. So if the dependent variable is categorical, then it is a classification problem. So for this one, we can use linear regression. For this one, we have to use logistic regression or any other classification models. But now our goal is to understand about the logistic regression. So how this logistic regression works? So logistic regression is a mathematical model that gives the probability of an event. So we all know that the probability value lies between 0 to 1. 0 and 1 are inclusive, and I can say that the probability value lies between 0 to 1. So now you may be getting a question, how is that possible? We are getting a probability. When you say probability, it is a numerical. Then how do you say that logistic regression is a classification, right? So you will get the answer soon. So now look at this. This is the linear regression part. You can see like x-axis and y-axis. In x-axis, we have independent variable. In y-axis, we have dependent variable, right? So let us take the same example of number of hours of study and the result one. Correct? So either the result would be fail or pass. Okay. So what I'm going to do now, fail, I'm taking like a 0, right? Pass, I'm taking like a 1. So let us now try to understand this. So here there is a set of data points in which the data says that fail, and here it is for pass. Okay. So we got X and Y data points like a 1 hour, fail, 2 hours, fail, 3 hours, fail, 4 hours, pass, something like that, right? So when you plot it, this is how you would be getting. Now what we have to do, we have to fit it with a straight line. Say we are fitting it with a straight line. Once you fit it with a straight line, what do we get? Y is equal to mx plus c, right? We know that m stands for slope, c stands for intercept, X stands for independent variable, Y stands for dependent variable. Correct? In this case, when you fit with Y equal to mx plus c, what would be the range of values of Y? It would be from minus infinity to plus infinity, right? Minus infinity to plus infinity. But what is the point I told you about logistic regression? It calculates the probability. When I say probability, the values would be ranging from 0 to 1. But here, I'm saying that it is ranging from minus infinity to plus infinity. In such case, how can we make it to fit into 0 to 1? Right? So, in such case, right, how the logistic regression is working is like, instead of fitting it with a straight line, we try to fit it with a sigmoid curve. Sigmoid curve. Yes, curve you can see. Right? We try to fit it with a sigmoid curve, which is nothing but yes curve. Right? So when you try to fit it with a sigmoid curve, what would be the equation? Right? It is very simple. Let me tell you. So the equation would be function of y is equal to 1 by 1 plus e power minus y. We know that what is y? What is y? We have already discussed that y is equal to mx plus c. And also I told you that y would be ranging from minus infinity to plus infinity. So now if you substitute here any values between minus infinity to plus infinity, the function of y would be ranging between 0 to 1. So you can check out this. Say, first you consider y is equal to minus infinity. So function of y is equal to 1 by 1 plus e power of minus y, right? So minus of minus infinity become infinity. Calculate it. Function of y is equal to 1 by 1 plus e power of minus y. Calculate it. Definitely, you will be getting the answers of 0 and 1. So, any values, whenever we get between minus infinity to plus infinity, will definitely give us the values ranging from 0 to 1 when you fit it with a sigmoid curve. Correct? So in linear regression, the dependent variable is numerical. In logistic regression, the dependent variable is categorical. In linear regression, we can solve regression problems. In logistic regression, we can solve classification problems. In linear regression, we fit with a straight line. In logistic regression, we fit it with a sigmoid curve. In linear regression, the equation of a straight line is y equal to mx plus c. In logistic regression, the equation of the curve is a function of y equal to 1 by 1 plus e power minus y. In linear regression, the output would be ranging between minus infinity to plus infinity. In logistic regression, the value would be ranging between 0 and 1. Right? So you can see now 1 by 1 plus e power of minus y. Y is actually written like b naught plus b1x, which is nothing but mx plus c, right? C plus mx. So if you use only linear model, we will write like y is equal to b naught plus b1x. Now, you can see like here we have 0 and 1, and we have some data points here. This is according to the size of the tumor. We are predicting whether it is malignant or not, right? So malignant is the dependent variable. So it is taken in y-axis. According to the tumor size we are predicting. So tumor size is independent variable. So now the points are being plotted. Okay. And now people will get generally some doubts like, we are getting the probability values ranging from 0 to 1. How do we say that like which category or which class it belongs to, right? So just take a very simple example. You just write an examination, right? Say R and result. So you study for 1 hour, maybe fail is the result, 2 hours fail, 3 hours pass, 4 hours pass, 5 hours pass, and so on. It is just an example, right? So now, if you ask me a question, how do you say that it is fail? Because definitely there would be something in between about the marks. So we may be having some marks criteria here. There would be a threshold of marks. It could be like if a person is getting more than or equal to 50, then we may call it like pass. Or it could be 35, it could be 40, right? So definitely there would be a threshold. In the same way, by using the threshold. So in this case, if you see, it's looking like 0.5, right? It's looking like 0.5. So what do we do here? Say these data points are plotted, these data points are plotted. We just fit it with a straight line. Now let's say I want to figure out for this particular data point. So just you extend this data point, threshold is over here, but actually when you extend it, it is not connecting with the threshold, right? It is lesser than threshold. So definitely we can say that no. Now, if I fit with a straight line, what is the challenge? Let me tell you what are the challenges that we will come across. Say there are some outliers here. So when there are outliers, what will happen? Definitely there would be a shift in the line. Say for example, now line is getting shifted like this. Correct? So now I have some other data point. Now I have some other data points like this. For example, over here. Okay, here I want to figure out for this particular point. If I am extending this, right? So now the line is actually changed over here, correct? But according to this, right? If I'm extending it, where am I getting? I'm getting no, right? Because it is lesser than threshold. But what is the actual result? Yes. So when there are outliers, it is leading to the problem of misclassification. Let me explain with another point. Say, for example, I want to consider for this point. For this point, if you see, it is actually yes. But when I extend this line, you can see that it is lesser than threshold. So it will give the result like a no. Correct? So it will basically lead to the misclassification. Right? So that's the challenge. We never fit it with a straight line. Instead of that, we can fit it with a sigmoid curve, like a S-shaped curve. So let us now try to understand about the metrics in logistic regression. So what are the metrics in logistic regression? To understand this metrics in logistic regression, we will take some of the images, right? So just assume that I just make a model now, right? I am just making a model. So what is the model I'm making is I'm trying to predict whether it is a cat or not a cat, right? I'm making a model to predict whether it is cat or not a cat. Say I have some cat images here. I'm making a model, right? Say my model is predicting that it is a cat. Here my model is confused and it is thinking that it is saying that not a cat. Okay, for example, it is saying that not a cat. Okay, so this one it is saying, for example, it is saying like cat, right? It is the prediction of my model, right? So here it is saying like again, it's saying not a cat, for example. Here again it is saying like a cat. Here again it says not a cat. It is correctly identifying and saying like not a cat. Here it is saying, say for example, cat. Here it is saying not a cat. And here it is saying cat. So let us now try to understand what do we mean over here, right? So now if you look into this one, it is predicting correctly. Here the prediction goes wrong, right? So let us now try to understand about all the criteria. It is very important to understand this concept because most of the times people get confused with this true positive, true negative, false positive, and false negative, right? So I will make it very clear now. First of all, how to understand this concept, okay? How to avoid the confusion, let's see. So you need to understand four concepts. One is like true positive, okay, true positive. The next one is say true negative. Okay, let me write with white. The next one is false positive. The next one is false negative. I'll give you a hint now. First step, step one, look at the prediction. Okay, look at the prediction and say whether it is positive or negative. So what is positive? Say this is positive and this is negative. So first you need to look into the prediction, positive or negative. Step number two, compare with actual and say true or false. How can I understand this? Look at this one. First, what we have to see, prediction, right? So the images, whatever you can see here, they are actual. And these, whatever I have written, these are actually prediction, correct? So first write for prediction. Prediction is what? Cat. Cat is what? Positive. Compare with the actual. That is the second step, right? So now compare with the actual. Actual is also a cat, right? Prediction is cat. Actual also it is cat. So true or false? Exactly true. Look at this one. Not a cat. Not a cat means what? Negative. Is it a cat? Yes. Not a cat. But actually this is a cat. So which means it is false. Cat, right? So positive. Is it a cat? Yeah, true. Not a cat. Negative. No, it's actually a cat. So it is false. Cat, positive. Yeah, it's a cat. Not a cat. Negative. But if you look into this, yeah, it's correct. It's not a cat. Right? Likewise, I'm writing here. My model is predicting cat, which is basically positive. No, no, it's not a cat. False. Not a cat, right? Not a cat means what? Negative. Yeah, that's true. It's not a cat. Again, here it is saying positive. Yeah, that's my model is saying cat, but it is not a cat, right? So it is false. Just look into this and get a clarity about it. It is predicting cat, so positive. Compare with actual. If it is the same, true. If it is opposite, then false. I'll give you 1 minute time. Just look into this. Correct? Let us go back to the previous slide now. True positive. The actual label for that column was yes in the data set, and our model also says yes. True negative means what? Both should be no. False positive means what? Predicted says yes. First, you should look for predicted, right? Predicted says positive, which is yes, but actually no. So it is false positive. What is false negative? Predicted says no, that is false, which means actually it is yes. Hope it is clear. Okay. So now let us look into the next one. about the confusion metrics, which is also very important for interview perspective, right? So let us now try to understand about it. Say what we have taken here is predicted class, and here it is actual class, because we were talking about two, right? Predicted and actual. And also we were talking about positive and negative, right? Positive is written here as 1 and negative is written as 0. You can see that. Let us now try to understand this. In the interviews, they would exchange it, and in any form they may ask you. So it is very important to understand the concept. Do not memorize it. Do not memorize it. Okay. So my model predicts positive. So I'm going to write for this column. Okay. I'm going to write for this box. First assume that nothing is there. Right. First assume that nothing is there. I'll show you. We have only this, right? Negative, positive. You can also exchange it, right? Okay. So first, what we have to look predicted. So if I'm going to write this predicted as positive, actually it is negative, so false. Predicted is negative. Actual also negative. Yes, it is true. If I take this one, predicted is positive. Actually also positive, so true. If you take this one, predicted is negative. Actual is positive, which means false. Let me know whether it is clear or not. Okay. Let me repeat it once again. If I'm going to fill this, first we need to look into for predicted. Predicted negative, so negative. Actually also it is negative, so true. Predicted positive. Actually it is negative, so it is false. Predicted is negative, so negative. Actually it is positive, so false. Predicted is positive and actual also positive, so it is true. Hope it is clear now.